Hello, my friends. I hope you're doing great. Here we are with 9-7. Can you believe it? We are cruising through Chapter 9. Good news. The last couple lessons we have here, not too bad with Chapter 9, okay? We've gotten through the really tough part with all of our different ways to solve these quadratic equations. So, there you go. Anyway, systems today. So, blast from the past. You'll find that systems of quadratics, guys, are super easy. And here's the deal, they can't really make them that hard. One of three scenarios will happen. 2 answers, no answers, 1 answer. Okay, there you go. We're typically going to get 1 quadratic equation and 1 linear equation. That's why, if you notice, one of these takes our parabolic shape. One of these takes a linear shape, okay? And again, how many times those lines meet each other is how many solutions we have. So here they intersect or meet twice, here they never meet, and here they meet just 1 time. As you have guessed it, of course, we will have an ordered pair, an x and a y value for our answers, so let's make sure that we find them, okay? Again, sometimes they can be as simple as this, right, if we think about graphing. Again, here are our 2 equations. This one's our quadratic one. There's our linear one. They've so nicely been graphed on Desmos for us right here. Again, what are our solutions, guys? So, obviously, it doesn't take a brain surgeon to figure out these 2 ordered pairs here and here, right? 1, -2. Write this over here. 1, -2. That's an answer. As is 2, -3. Okay? So these are the only 2 combinations of x and y values that we can substitute in here for x and y and make both of these true at the same time. Okay? Again, all of the ordered pairs on the red line make this true. All of the ordered pairs on the blue parabola will give us true statements here. But there's only 2 ordered pairs in the whole world, and they're these 2 right here, that will make both of these true at the same time. Simultaneous equations, sometimes also referred to as systems, okay? So again, that's great. If you're a step person, here are the steps to solve algebraically these systems, right? We're going to solve each equation for y, then we're basically going to substitute one expression in for y on the other one, and then we're solving for x. This is why we solved so much stuff. All right, here we go. So best case scenario. This one, already both solved for y. Great, good news. I know that y is equal to this and y is equal to this. So I'm going to replace this y with this expression. Why do we do that? Because I can't solve a 2-variable equation. But what I can solve is a 1-variable equation, right? So I can solve 2x equals x squared minus 4x plus 5, okay? But what I think we should do here is move this x over here and take a look at what we get. So we're going to add 2x. So we'd add 2x over here. So minus 2x plus 5. I'm just going to say equals 0. Okay, guys, all I did, write this over here again. I know a lot of us like to have 0 on the right-hand side, so that's why I did that. Okay. Quickly ask yourself, will this factor? No. No, it's not, right? 5 doesn't have many factors, 1 and 5. Neither of those will give me this. Okay? All right. How do you guys want to solve it? I don't really care. Somebody said quadratic. We can do quadratic, guys. That's fine. Okay? No, we don't want to get rid of that just yet. So A, B, and C. So A is 1, B is -2. Wait a second. Yeah, never mind. We're good. I'm looking here going, B should be -4, and then I wrote down 2. Okay, yeah. So B is -2, and C is what, 5? Okay. So x equals the opposite of b plus or minus b squared minus 4ac all over 2a. Okay, so let's plug in what we know. So the opposite of b is going to be 2. Okay, b squared is 4 minus 4 times a, which is 1, times c, which is 5, all over 2a, so just over 2. Okay. Let's clean up our discriminant. That's our new word. Remember that from the other day. 4 times 1 is 4. 4 times 5 is 20. So this should turn into 20. Okay. 20. Great. Now what do we do? Well, we can probably mess with that a little bit. X equals 2 plus or minus the square root of negative 16 over 2, right? And I mean, that's the number 4, right? So I should simplify that down, shouldn't I? No, we shouldn't, okay? Remember, try to type that into your calculator. What's going to happen? No, really, go ahead and do it, okay? It'll give you an error message, right? Why will it give you an error? Because there is no number when you multiply it by itself that we would get a negative 16, okay? So what happens here, guys? Special case, no solutions, okay? So this is a no solution. Kind of evil that we would start with a no solution right off the bat. But you know what? You guys are tough. You can handle it. Okay? I promise we won't do that again. All right? Okay, here we go. We can model car wash sales by this function, and prepaid car wash sales can be modeled by that linear function. Okay? Where X is the number of months, okay, and Y represents the total revenue. Solve a system to find the first month after May in which revenue from the car wash sales is equal to that one. There we go, okay? So in other words, we want to find out when these two are equal to each other. I do not have a lot of room on here. Let me squeeze this up. So basically, guys, what we're going to do is, gosh, I wish we had more room. We're going to take this negative x squared plus 8x minus 4, and we're going to set that equal to the other one, 2x plus 5. Okay? And then, guys, I just want to solve, I mean, basically, we're solving this equation. Okay? So, again, let's gather all of our terms over on one side. So let's move the 2x and the 5 over here. They're going to combine with their like terms. So, wait, you don't want to do that? Why don't you want to do that? Oh, because you're afraid of this negative sign? Okay, that's fair enough. Right? If you see that and you would rather move this over here, sure. It's just going to be moving 3 terms now, but we can do that. So we're going to add x squared over here. Of course, it's not going to combine with anybody. Right? So I'm going to get x squared. Then we're going to move this 8x over here. We're going to subtract it. 2x minus 8x is negative 6x. Okay? We got to move this 4 over here. Right? We're going to add 4. 5 plus 4 is 9. Okay. There we go. Now we're getting somewhere, okay? We need to solve this however we want. Okay, I'm looking at it. My first thought is factoring, right? Because I think factoring is pretty quick, pretty painless. So factors of 9 that add up to negative 6. Yeah, I think there is a pair, isn't there? Okay, so guys, we would factor this, and it will factor into x minus 3 and x minus 3. I'm going to just say equals 0 over there. Okay, again, if you don't believe me, go ahead and FOIL that, right? It'll work. Okay. Zero product property. Set each expression equal. And in this case, I really only have one expression because they're both going to give me the same answer. So there you go. So it wants to know, define the first month after May in which the revenue, right, is equal. Well, we're 3 months after May. So June, July, August is the 3rd month after May. So in August, they will have revenue that is equal to each other. Okay? And guys, that's what we're doing. Not terrible. We've clearly done better things. We're at the end of this already. Beautiful. Solve this system algebraically. Great. However you want to do this, I'm going to say 4x plus 3 is equal to negative x squared plus 3x. That is a terrible square. Minus 1. Okay. Again, probably a good idea, right? We're probably more comfortable having a positive x squared. So let's move everybody over here to the right. So I'm going to move x squared over here. It combines with no one. When I move 3 over, it's going to combine with this guy right here. Right? We're subtracting it, so this is going to give me plus 1x, or just x. Again, we're going to move negative 1 over here. We're going to add it to the 3 to make 4. Equals 0. Okay? All right, how do you want to solve this one? Well, again, I think factor, so I'm going, okay, hey, 4 has factors of 1 and 4, 2 and 2. None of those add up here. So that doesn't work. I can't do square roots because I got this middle term. Maybe I would want to do completing the square, but remember, I'm going to take half of this and then square it. So half of 1 is a half, and then I square it, and it turns into a fourth. I don't really want to mess with that. Let's do quadratic on this one, okay? So A is 1, B is also 1, C is 4, okay? So here we go. Plug in what you know. X equals, the opposite of B, plus or minus B squared minus 4AC. I think bad things are going to happen here, all over 2A. So the opposite of B is negative 1. B squared is 1 minus 4 times A times C, all over 2 times 1. Should we even go any further? Maybe, because maybe you don't see it yet, right? Let's keep simplifying this down right here. We're going to move up and over here. So x equals negative 1 plus or minus the square root of, that's right, you guessed it, negative 15 over 2. Maybe now that we see it, okay? So again, the moral of the story today is you've got to be very careful with this calculation in here, okay? So our discriminant in this one turned out to be a negative. All right, which again, when that happens, we don't get a solution here, right? We're hoping for 2 numbers, but in this case, that doesn't happen, okay? So anyway, if we see them on a graph, go ahead and graph it like we normally would on Desmos. Look for those ordered pairs. If we see this algebraically, guys, we can solve it really with any method that we want. So whatever you feel comfortable with. But remember, square roots, factoring doesn't always work. Completing the square, quadratic always work, okay? Good work. See you later.